All right, I am excited to introduce our next speaker here. And as we get his slides and everything up, I just want to give a quick introduction. We've got Tunde Olu-Isa. He's a managing consultant at Oteemo. Now, prior to that, though, he's got a lot of experience as an SRE, a site reliability engineer at Heptio, at IBM, as a DevOps engineer. And so these are all of your foundational cloud-related activities that you want to have in place to successfully move to the cloud and use solutions like Kubernetes. So Tunde, I'm going to turn it over to you, and so you guys can get your slides going.
Awesome. Thanks, Frank. Welcome, everyone. Thanks for joining today. My name is Tunde, and I'm a managing consultant at Oteemo. Oteemo is a consultancy agent focused on security, cloud native transformation, and working with commercial and federal government. Today, what I would be talking about is Kubernetes security best practices. And I tend to think about it as 10 tips towards navigating security in Kubernetes. Part of the challenge is as more people adopt Kubernetes is thinking through how you secure the whole architecture, right? This starts from the infra all the way to the Kubernetes platform itself, and also the workloads that run on top of Kubernetes. Doing this has proven not to be an easy task. And so part of what this talk does is kind of helps you navigate those best practices for employing security within your environment. So moving on. And so today, as part of this talk, part of what we'll be talking about and the 10 tips we'll be looking at is, keeping the cloud provider platform secure, running security tests in development environments, cluster authentication, looking at network security and things like micro-segmentation, using policy and governance, runtime security, application secret management, data protection, auditing, and container security. So let's get right into it. The very first one here is, keeping your cloud provider platform secure. Depending on wherever you're running Kubernetes, be it on AWS, Google Cloud, or Azure, one of the first things you want to make sure is that you keep the infra and the cloud provider platform secure also, right? This includes things like using limited security group rules, employing best practices, network access controls for Kubernetes in this case, minimizing things like your IAM footprint for Kubernetes, right? Ensuring that the roles and the permissions that are assigned to the Kubernetes platform itself are essentially what it needs. And then the other thing is also things like your object storage, right? An example would be on S3, right? Ensuring that the contents that you have that are related to your Kubernetes environment are also secure on that S3 bucket. So moving on and just coming down to the aspects of Kubernetes that make up your infra. Part of this is things like your Kubernetes API server, right? This is the art of the Kubernetes system in this case. And one of the things you want to make sure is that you limit access to the Kubernetes API server. And this can be done in several ways, right? This could be done by either putting the Kubernetes API server behind a VPN, or running this inside a private subnet. And in addition, also is using things like security group and network access controls. This also applies to etcd, right, which is also another critical component of Kubernetes, which is responsible for the object, which is the object data store in this case. And in general, right, following the cloud providers' security best practices is one of the things you want to consider while keeping your cloud provider platform secure. So that's the first one. And moving on to the next one here is running security tests in development environments. Like this is something that based off of prior experience implementing security within Kubernetes platform that has kind of constantly shown its importance, right? This is something that can't be stressed enough. What you want to do here is you want to mirror your production environment in a test environment, and then identify your attack vectors and making sure that you're testing those for vulnerabilities. And also, in a case where a critical vulnerability comes out, you verify within that test environment that you're able to immediately remediate those issues. So part of that is, test environment should mirror your production configurations. You want to verify that the exploits, known exploits are being prevented by your current security measures, right? One thing is to implement a security measure. The other thing is to make sure that those security measures are actually doing what it's designed to do. And lastly, you want to make sure that the security exploits that are proven within the development environment are vetted within that security test environment. Let's moving too fast. The other thing here is cluster authentication and cluster authorization. So now we're moving into the Kubernetes platform itself. A common theme with Kubernetes is how you authenticate with it, right? If you think about how Kubernetes is designed, people tend to see users as service accounts, but those users do not necessarily have attributes that could be mapped back to your identity access management. And so part of what Kubernetes supports for authentication is OpenIDC, which is Open Identity Connect token. And certain tools that support that is DEX. And DEX in this case, what it essentially does is it's an identity provider, but doesn't necessarily store user information in it. So that it's able to connect to upstream identity providers like GitLab, Keycloak. And then you can then attribute certain users to specific roles within Kubernetes. And what this does is, in the case where, maybe say you're running in a multi-tenant environment, you're able to help users limit accidents, right? An example would be somebody from a separate namespace deleting another namespace that they shouldn't be able to. This also helps with, in the case of a compromise, right? This limits the access of the specific user in this case. So ways that you can further, strengthen authentication and authorization here is leveraging Kubernetes primitives like RBAC. There's an RBAC object in Kubernetes, role-based access control, that allows you to map roles using role bindings. You can then map the users that are provided by your identity provider with the role binding to the specific roles. And then one of the things you want to do is to make sure that as you define roles, that those roles are using the least privilege principle. So this is all moving down away from things like authentication and authorization, and then moving into network security and microsegmentation. And in Kubernetes today, part of how that is being facilitated is using things like network policy. So network policy is also a Kubernetes primitive, which essentially helps you create a network boundary between workloads and also between services that are running outside of your Kubernetes environment. Some prerequisites for you to be able to employ network policies using tools like Calico and Cilium and Entra. These tools are what's referred to as container network interface tools, and specific CNIs do support network policies. And so an example of how you would use a network policy is to limit communication between two namespaces. So you could have a namespace that is responsible for maybe identity checking and a namespace responsible for maybe web services. And so maybe you don't want those two namespaces to talk to each other. So you can then define network policies, or what most people know as firewalls, to prevent these two namespaces from talking to each other. Another common use case here is preventing workloads from talking to the cloud provider's instance metadata endpoint, right? Where something like this becomes very important is in a case where a workload has been compromised. Now the attacker in this case can't use that workload to gain privilege into the worker nodes or outside of even that Kubernetes environment. The next thing here is policy and governance within Kubernetes. So this talks about how you do things like how you enforce company or organization-wide policies within the Kubernetes system. An example of this would be enforcing the instance types, right? Say the company is trying to save costs, right? You could use policy governance. But from a security perspective, right? Policy and governance in Kubernetes enforced using things like admission controllers, right? And some of the things you can use Kubernetes admission controllers to do is to enforce maybe read-only file systems. Another thing would be to enforce use of non-privileged pods. And there were tools inside of Kubernetes in the past that made enforcing policy and governance a lot easier. And the feature in this case is the pod security policy. But this pod security policy is being deprecated or planned to be removed in the more recent Kubernetes versions. And so what we tend to see the industry lean towards and what we've been employing more recently is to use centralized policy systems like OPA Gatekeeper and Kivano. And so these are domain-specific languages that allows you to specify policy to prevent access to things like restricted container registries and enforce organization-wide rules. Next on the list here is runtime security and monitoring. So as you run workloads inside of Kubernetes, how do you ensure that the nodes that Kubernetes is running on aren't being malicious activities aren't taking place on them? And so what we tend to do here is to recommend tools like Twistlock and Falco, which are runtime security tools that allows us to identify, say, processes that try to have like a privilege escalation, right? And also reporting any case of like a malicious activity that's happening on that runtime. And so one of the good things about Falco and Twistlock is that they conform to known security standards like NIST, CIS, and SOC. So it's highly important that you have a tool like Twistlock within your environment, and you also have a dashboard that allows you to be able to see what's going on as workloads run within your environment. An example here would be, say, for some reason within that environment, somebody creates a shell, or in an immutable container, right? Say you see somebody exec inside of a pod that is running inside of production. That's a red flag, right? So that's something that you want to make sure that you're tracking. And so again, that kind of stresses the importance of having runtime security within your environment and immediately identifying when these things happen. The other thing here is secrets management. As you run workloads within Kubernetes environments, also, a lot of these workloads need credentials for either login purposes or even reaching out to other endpoints. And so securing those also becomes very, very important, right? And it starts from, the object store. When you define an object inside of Kubernetes, take, for example, the secret object. Behind the scene in the etcd data store, those secrets by default are stored in plain text, right? So anyone who has access to, say, for instance, the etcd backup could literally open up that backup and just see all the secrets that are inside of that environment. And so one of the advices here is to encrypt etcd, right? So you could use like your KMS to encrypt etcd in this case. And then going forward, like secret management generally within Kubernetes, you can leverage tools like Vault, Sealed Secrets, SOPs. SOPs is also a CNCF tool that you could also use for encryption of secrets and decryption of secrets. So you could just decide on which one of these tools that you want to use based off of your company requirements or whatever fits into your needs. The next thing here is data protection and CV remediation. Part of running workloads inside of Kubernetes is a way to be able to address CVEs. And in the past, one of the ways you would do this is either doing an in-place upgrade. But the challenges that come with doing an in-place upgrade is that you can't necessarily tell what's going to happen, right? And so what we essentially, a best practice here is to create like a new cluster and then migrate those, a new cluster running a version that the CVE has been fixed in, and then you migrate those workloads from the old cluster into the new cluster. So essentially doing a build brain migration. And one of the tools that facilitate that is a disaster recovery tool known as Valero, and also Casting is also another tool within that space that facilitates disaster recovery and data protection. Another thing that we highly recommend here is to have an upgrade plan to address CVEs beforehand. So this is a well-defined document that your SREs can refer to when, say, a CVE comes up. In addition to this is also subscribing to the Kubernetes mailing list or looking at Kubernetes release notes prior to doing any upgrades. Typically inside of the mailing list and release notes, when the CVE comes out, those are being communicated over there. And also in the release notes, the CVEs impacting that specific Kubernetes version is also identified. Lastly, here is with every Kubernetes API object, they typically have an API version that kind of tells you the stability of that API. And it goes from alpha, beta, and stable APIs. So one of the things that we highly recommend here is to use stable APIs within Kubernetes, right? So more recently, most of the more widely used API objects inside of Kubernetes all change their API versions to V1s, which are typically the stable APIs. So that's kind of what is recommended in this case, right? Because an API that is either in the alpha stage, that is in the alpha stage could at some point be removed, but anything that's in the stable phase is something that would be continuously maintained. The other thing here is auditing. So say your Kubernetes cluster gets compromised. How do you identify the scope of that compromise? How do you tell the footprint of that attack? Or how do you identify what has been done within that Kubernetes environment? And so what you do here is you enable auditing. So auditing, it's a Kubernetes feature that you can enable that allows you to specify policies. Using policies, you can specify what kind of auditing you want to do inside of your Kubernetes environment. And there are documentations in the Kubernetes community that kind of helps you with a baseline to start with. And so one of the things here is that you want to have an audit policy that definitely checks and audits, the important aspects of your Kubernetes environment. As you also define audit logs, one of the other things you also want to ensure is that those audit logs don't reside on the Kubernetes nodes. And so what you want to do is you want to store these audit logs in a centralized logging system and also have like a visualization dashboard that you can use to filter these audit logs. And then the other thing is it's also important that you have someone who understands the pieces of this audit logs to be looking for, right? So what should you be looking for, like in the case where something goes wrong? And then how do you respond? What's the incident response process in the case where, say, a malicious activity is identified using audit logging in this case? So part of this is having something like a triggered alerts based off of specific audit events. An example would be, say, somebody execs inside of a pod in production. That could be something that you audit and you take actions based off. And the last one in here is the container security itself, right? So this is doing vulnerability scannings of those containers within the pipeline, leveraging things like security context, which are Kubernetes constructs, and using secure computing and AppArmor, disabling privilege users within the Kubernetes container, ensuring that containers running inside of the Kubernetes environment are also a read-only file system. Because if you look at most exploits that have become known within the last couple of last couple of Kubernetes releases, is that maybe an attacker writes into either /them directory within the containers, right? So enabling read-only file system in this case would prevent those kind of exploits. Another one is avoiding the use of host network in this case. And host network in Kubernetes essentially means that you're leveraging the host IP instead of the container network interface provision IP for your pods. And so in this case, if a pod using the host network gets compromised, then an attacker could then use that pod, the host network, to then talk to whatever it has access to. In addition to some of these container security best practices, leveraging things like SE Linux on the worker nodes, and also control plane nodes to kind of like add in the container itself. And then some other tools for securing containers is leveraging, sandbox containers like gvisor and Kata containers, along with some of the other containers you have within your environment. And then going down a layer further is, outside of that container, is making sure that the code that is used to build, the code that is running inside of the containers in this case have gone through static code analysis and third-party dependency checks. Some of the other things here is leveraging tools outside of Kubernetes for security. And one popular tool that you can use here is using an Heptio service mesh. One of the features that Heptio provides is mutual TLS, which allows you to provide a workload identity to separate workloads as they talk to each other. And so a certificate is presented to each one of them, and that limits the chances of those two workloads being compromised as they communicate with each other. A known best practice is also to disable auto mount of service accounts within Kubernetes. Service account is how we provide identity to workloads in Kubernetes. So through that identity that is provided, you can then talk to the API server. And so not all workloads need to talk to the API server. And so a best practice here is to disable service accounts for those workloads. The other thing here is also configuring CNIs and ingress controllers to prevent denial of service. Tools like Calico by default already have settings and configurations to prevent this, but on your ingress controller side, you can also make changes to address things like DDoS from happening. Some other ones here is also preventing noisy neighbor issues, right? Say, for instance, a workload gets compromised within your environment. How do you limit the scope of that compromise? And so what we tend to recommend here is using node groups, right? So Kubernetes has a concept of taints and tolerations. And so what you could do is you could prioritize workloads into specific node groups, and then also gate the resources that are provided to those node groups, or even the IAM roles that are provided to those node groups to exactly what it needs. So node groups could be also essential to keeping your containers secured. More recent features that could be used to secure your Kubernetes workloads, immutable secrets and config maps. I think this were introduced in 1.19, which essentially means that now you can create secret objects that can't be modified in place. So that helps you ensure that that the secrets and variables that you have can't just be modified in place and changed into something else within production environments. The other thing here is persistent volumes running inside of production. How do you ensure that application persistent data is secured? So one of the recommendations here is to ensure that your storage class is doing encryption, right? So say, for instance, you're running EBS in production, right? You can enforce encryption of those persistent volumes. And lastly here is to adhere to port security standards. The Kubernetes port security. So this is standard that was released not long ago. So that's also something you can look at and ensure that you're following some of those guidelines in there to keep your Kubernetes environment secure. So again, just to recap, some of those key takeaways is one, you definitely, as you start to adopt Kubernetes, you want to make sure that you're securing the cloud platform that Kubernetes is running on. You also do want to ensure that you understand the platform's attack surface and you're continuously improving your security posture. And then third, you want to ensure that your cluster authentication and authorizations are defined with least privilege in mind. And then you also have things like network policy used for micro-segmentation of workload and tenants. And then the other thing is to do governance and policies within your environment. You leverage centralized policy systems like OPA and Kiveno for that purpose. The sixth one here is using runtime security and monitoring tools to identify runtime anomalies or malicious behaviors within the runtime. Keeping Kubernetes secrets secured, using centralized secret management tools, and also encrypting secrets. That's the seventh one. Establishing CVE remediation procedures and configuring data protection is another very, very important one. And then logging changes taking place in clusters using audit logs is a nice one. And lastly, port security standards. That said, I think that's everything. I want to say thank you for everyone for joining. Again, at Oteemo, you can find us at www.oteemo.com. We're also hiring not for only Kubernetes roles, but generally a lot of IT roles also. And feel free to reach out to me at that email. And also HRs could be reached out to at careers@oteemo.com. I did realize that I do not have any of my social media contacts here, but I could drop that in chats just in case. But thank you all.
Hey, great stuff, Tunde. You know, I think we have time for just one question, and then we'll take it back over to chat after that. Alejandro has a question about tooling, right? In terms of, hey, you mentioned some free tools. There's Falco, which is a CNCF project. You mentioned Twistlock, which is a commercial project. Kind of what percentage of your customers are using some of these commercial tools, and why are they going to some commercial tools versus some of the free ones? And how do they make that determination?
So it depends on what exactly the team needs, right? And I'll pick on the specific tool in this case, which is Falco for container runtime security. The open source version of Falco doesn't necessarily have a UI, and it doesn't also come with support. So that could be a reason why some of our customers tend to make the decision to go with the enterprise solution in this case. And so that's typically the biggest one.
Yeah, makes a lot of sense. You also mentioned at the very beginning, kind of managed Kubernetes, AKS, EKS, GKE. What percentage of your customers are on those managed ones versus kind of doing it on their own or on-prem, if you will? And why do they make that change, that trade-off?
So this might not necessarily be like related to the security of the platform, but it's more, again, it's around the structure of the company, the skill sets that the company has, how much weight is the weight of Kubernetes and burden of Kubernetes is a company willing to carry by themselves. And so we tend to see customers move to manage Kubernetes based on like either team size or not necessarily wanting to deal with like burdens of managing specific aspects of Kubernetes like the control plane.
Yeah, perfect. Makes a lot of sense. Well, hey, Tunde, thanks so much for the great information. We're at time right now, so we're going to go ahead and move it over to the chat. But everybody, let's give Tunde a virtual round of applause. Thanks so much, and take care. And we will be back for the next session in about 5 minutes.
So thank you all.